Copyright in these lectures is either owned by the ANU or a third party who has licensed the ANU to use it. Students may use the recording for personal study only. No lecture may be communicated online, copied or shared without the prior permission of the ANU.
I still wanted to provide some additional help as much as possible. So what I'm going to do is I'm going to show you, well, firstly, a couple of weeks ago I did put, following a number of questions, I did put a spreadsheet online which I obtained from the RBA website, which can enable you to obtain risk-free rate proxies. Okay, so I've had a number of questions about that, and I thought it was a little bit inefficient for me to sort of tell people one by one, okay, even though I did mention it in class. I thought I'd just post it for you. All right, so I'll show you that particular spreadsheet. That's one. Two, I want to show you how to, like I've shown you how to estimate betas using the index model. Okay, that's a univariate regression. I want to show you how to estimate the Farmer-French model, all right, which I've provided factors online. So that's going to be what we'll be going through today. Just log into Waddle because I've just put all of this. Sorry, I'll reveal this all in a second. Just logging in now. Are there any questions about the assignment at this stage? I haven't had a great deal of number of groups sort of contact me back regarding who's in their group. Please do so if you haven't done so already. Just send me an email and just say, here are my group members. Okay, this is our group. And that way what I'll do is I'll then put it into Waddle and identify you as a group. Okay, that way things don't get lost. All right, so please do that if you haven't already done so. I think I've heard back from about 20 groups, okay, but there should be more, okay, give or take. Okay, it's about 20 I think now, okay. But that's important, just so I can keep track of who's who and what the composition of the groups are. Okay. Here we are. Okay, so our Waddle page. So I've done a couple of things. Now there is an announcement up there which you've sort of seen from weeks ago that I put, saying that I put Farmer-French factors online. I'll show you how to work with those in a second. But I've also posted something under course announcements, and you know, I didn't really want to clutter the top of the page so much, so I didn't post it there, but I did post it down here. Under course announcements. So periodically do go and have a look in there. I've only posted a few things, okay, but where you'll find this particular post here, where I say risk-free rate proxy data. Now I did this in class. I did direct people to the Reserve Bank. Okay, they have a website containing a list of statistical tables, one of which is this one. And what I've done, just to make it easier, because people are still a bit confused, I thought I'd post the spreadsheet here. All right, that way you can kind of just go there, no fuss. I don't want people to sort of waste time worrying about where to get risk-free rate proxies from. So I've provided an Excel spreadsheet below, okay, which contains proxies for the risk-free rate. Now, if we open up that spreadsheet there, I'll just save it to the desktop. Okay, and we'll open that up and have a look what it looks like. Now, if you go to the RBA statistical tables website, you scroll down to interest rates, you'll find it there. This is the monthly data, okay? But just be very careful with this, and I'll explain to you why that is. Okay, so these are quotes monthly, but I want you to bear in mind that each of these rates are annualized. So use whatever method you wish. You can simply divide by 12 if you want. I don't mind. Okay, convert that to a monthly rate. They've all been annualized, but they are quoted monthly. Okay, that's what that basically means. They are stated monthly, but they are converted into an annual rate. So convert it back to a monthly rate for what you need to do. Now, which ones are applicable? Ideally, either this series here, being 3-month bank accepted bill rate, or you may wish to use the 1-month rate. Okay? Now, some students have kind of argued, saying, well, you know, if we are working with 5 years of data in our regression, we therefore need a 5-year rate. That's not true. Okay? We need a risk-free proxy. And by definition, a 5-year bond will certainly have a lot more risk than a 3-month or a 1-month rate. Okay, that's not how it works. You don't need to match the risk, because there is going to be risk there. So you don't need to match it in that sense. It's a very, very short term, either T-bill rate, okay, or a bank accepted bill rate, which is a rate at which banks lend between each other. Okay? There are numerous different things we can use as proxies. Now, you may decide to use a government rate, and if we sort of scroll over here to the right, we can see Treasury notes. Now, ideally, you'd use something like the 1-month or 3-month Treasury note, but that was ceased. Okay? So you're not going to have all of that data. Okay? So that's why I'm not recommending that. But most certainly do use over here, either the 3-month or the 1-month rate. Make sure you convert these particular figures here into monthly rates. Okay, so they're annualised. That means right here, 2.22 per annum. But that's the figure for November 2015. Okay, so divided by 12 or convert it into a monthly rate, that's fine. I don't mind how you do it, because the methodology is not clear in terms of how they've annualised, just that they have. Okay. And you may then use that particular figure in coming up with excess returns or risk premiums. Okay, are there any questions about that? Now, no doubt you will have sort of at least pondered the idea of risk-free rates so far for the assignment, but just so everyone is kind of clear on that, that's where it comes from. And I have put the Excel spreadsheet there so there's no more confusion. I don't want people to kind of worry about that so much. Okay. So again, do have a look under course announcements. There it is. Now, if I go earlier, so that was posted on the 6th of September. Okay, so a while back. All right. Now, if I go down here, has everyone seen this announcement? Okay, so I've asked you to kind of do some things with Farmer French factors in the assignment. These are the factors. So the idea here is you've got to include the factors. So we've talked a little bit in the preceding lecture about multi-factor models. Okay, but now what I'm going to do, I'm going to show you how to actually execute it, okay, and estimate the sensitivity of each of these companies to each of these betas, or each of these factors in a sense. So, you know, we can have a single factor model, okay, and with a single factor model, like say the CAPM, okay, the market is the major source of macro risk, okay, or common risk to all companies, and we can actually implement that empirically using the index model. That is, you just substitute the market, that market variable, you put in some kind of index, okay, and that's how you proxy for that. But sometimes we have additional factors, and one of them is the Farmer French 3-factor model, which is very famous, and the idea there is there's an additional 2 factors included, which arguably proxy for other things out there in the economy. Okay, even though they're firm specific, okay, the argument goes that certain unobservable factors out there will be captured by these. Okay, and there's a lot of evidence suggesting that it does provide a little bit more clarity on top of, say, a single factor model. So what I've done is I've gone away and I've estimated the factors. Now, these factors can be applied to any company for that month. All right, so what I mean by that is, let's just open this, and then I'll explain what's going on. So this is what it looks like. I know it's pretty generic, but all the information is there, right? Okay. So I've gone away and I've calculated these myself, okay, using as many companies as I could obtain data for. And That is provided here in this column, number of firms. Okay, so now there's about 2,000 firms approximately on the ASX. A lot of them are really, really, really small. Okay, a lot of those firms may only have trades a couple of times a month, so these ones are not included. Okay, so they're only sort of like the most liquid kind of companies, and there were certain criteria that I applied for inclusion. But even if they were included, okay, they wouldn't make really any significant difference anyway. So that's why I've only included the ones sufficiently liquid to get some kind of reasonable data from. So if you see here in the first column, month end, what that basically means is that's for the month July 2013, okay, August 2013, September, etc. And that's the beginning of the 60 months, okay, that you require. All right, so if we have a look all the way through down here, down to June 2018, which is the point at which your assignment kind of ceases. That's the end, okay? And 61, so there's 60 observations there, plus the labels. Okay, so each of these rows represents a particular month. All right. First one is the equally weighted return. The next one is the value weighted return. So I did say I would share with you, I would provide you with the market returns. There it is. Okay, so I've calculated returns based on an equally weighted basis. So what that basically means, of all of these 841 firms in the Australian market, which by definition would roughly be the 800 odd most liquid, okay? There's a lot of really tiny ones, you just simply don't have enough data points to calculate them. So that's why it's 800. Still a lot, and still reasonably accurate, right? So all this basically is, for each of those 841 firms, I calculated the return for that month, okay, added them all up, and then divided by n, which is the number of firms. Okay, so that's equally weighted. Value weighted, same thing. So what I basically did here is I calculated the returns and then multiplied by their weight, the amount that they represent of all firms as a percent in terms of size. Okay, and I redid this every month. All right. So if you wanted to choose, so I've had this question as well, should I choose equally weighted or value weighted? If you have value weighted data, always use that over equally weighted. Why? Because what that does is it gives more importance to larger firms. And that's generally how it will work realistically when you're looking at the market overall. The larger firms kind of dominate the picture, and that is reflected in the value weighted return. Okay? Whereas with the equally weighted returns, even if you have a really tiny firm, its returns are going to be given the same importance as the very, very large firms. So that's the difference. All right? So preferably use the value weighted returns if possible. Okay? And I've given them to you here. Now, as time goes on, we do have more firms included in the sample. Now, don't get me wrong, that's a huge number of firms. To do these observations with that many firms is very respectable. Even if one were to do the same thing on US firms, you'd only get potentially 2,000, when in fact there's many more thousands in the US market. Okay, so that's still very, very high. Okay. Now, these are the things that you might want to know about. SMB and HML. Does anyone know what these actually stand for? What does SMB stand for in the Pharma French context? What does SMB stand for? Not sure? It's a tricky concept to get your head around. The letters stand for small minus big. And what it is, it's basically the difference between, in the return for that month, between those of a group of small firms, the smallest firms of the group, minus the return for the largest firms of the group. Okay? And that's how Pharma French in the original paper defined that. Now, the reason why you can actually obtain these factors from a website, I'll show you that in a second, but they're different because that website includes all of Asia Pacific in the specific factors, not Australia, okay, only, which is why I've done this separately. So, you know, if you wanted to go and obtain this, you can go to something called the Kenneth French data page. Here we go, Kenneth French data, Kenneth French Nobel Prize. Ooh, Kenneth, okay, let's not go there. Good old Google, yes, giving us everything we need to find out. Okay, so what Kenneth French has done for many years, he has maintained a website of data where he's calculated a number of different things. And certainly go and have a look at some of the specifics of this. There's a huge amount of stuff here, so you don't really need that. But the most important are indeed the Farmer French factors. And if we scroll down, these are just summaries up the top, okay? But if we scroll down, US research returns data. Now, down here, Farmer French 3 factors, if one is doing research in the US market, they would simply obtain this data here, and you can obtain that in CSV format. But that's using the distribution of US firms, which is not applicable to Australia. Okay, so we're selecting Australian firms, so we want to do that. Now, Farmer French 5, there have been extensions upon extensions. Don't worry about that. I'll show you one of the extensions, which is the Farmer French plus Momentum, so it's like the 4-factor model, but we won't worry about that right now. So that's US data. If we scroll down further, these here are portfolio returns. Okay, so if you sort data into different portfolios, they actually do that across the US market. Scrolling down, industry portfolios. Probably missed it. Here we go. Developed market factors and returns. Knowing my luck, there'll probably be an Australian one here right now. No, there isn't. Okay, but the closest that we have in Australia, if you wanted to use that data, would be this one down here. Farmer French Asia Pacific, excluding Japan 3 factors. Okay, so you'd simply open that by clicking on the CSV there, and you obtain that in a zip type file. Okay, and this is what they are here. Okay, because they just consider Japan to be a unique example. Okay, so it's a completely different kind of universe of stocks with different characteristics and so on. But I prefer to just calculate them myself. Okay, but that's the rationale behind it. And Japan, from memory, is provided as a separate one. Okay, and you can see these here. Okay, there they all are. Okay, similar sort of thing. SMB, HML, and all you basically do here, folks, is you just run a regression of the returns for a given company. So you'll have your companies that you've selected. You'll have that firm's returns for the month, excess returns, as the dependent variable, and the 3 independent variables will be 1, 2, and 3. That's it there. Please make sure also that if you're expressing things as percentages, all the variables have to be as percentages. If you express them as decimals, all of them have to be as decimals. Okay, so that's common sense, but it's very important. Just make sure that they're expressed on the same basis. These here are all in terms of percent. Okay. So this is essentially like the data that I've provided you, but I've only limited. Now, there's no indication here how many firms they've used, okay? But I've done it just for Australia, so, because, you know, realistically, out in the real world, this is what practitioners should be using. Okay, so these factors should be constructed based on the universe of firms from which they come from, or the firms that they're working with. Okay, so I've expressed them here as decimals. Make sure you do the same. Okay, otherwise just multiply by 100, so it's expressed as percent, right? All right, so this is the data here. Okay, so you might want to incorporate that into your spreadsheet containing your monthly returns for your firms, and I'll show you how that works. Now, I'll just minimise this for the moment, and I want to show you an example which I've put together. Now, I put this together, I think I did this, originally put this all together last semester, I believe. Okay, but I don't believe that I actually used it as an example back then. So if you scroll down to workshops, there it is. And I've placed it in the workshop 6 folder, and you can certainly use this as a template in any way you wish. That's fine. All right. So this is fairly comprehensive in the way that I've done this. And what I've started with is really what you would have already seen. Okay, so remember when I initially showed you how to estimate betas, I showed you this spreadsheet. Okay, so what I'm going to do is expand on this using Farmer French factors. And please bear in mind that all of the data here is expressed as decimals. Okay, so please don't get confused on that. I don't care which way you use, the result's going to be the same, but just make sure that the scaling, the basis of it is identical, okay, across all of the data incorporated into your regression. So I strategically stuck with a much earlier period because it's, we don't want this to coincide with the period you're working on your assignment with, but I still want to be able to demonstrate this to you with sufficient detail. All right, so we started with returns data, and I showed you how to obtain returns data from Yahoo Finance. If you're in doubt, do come and see either myself or your tutor, okay, during consultation. But I did go through this in class. You can obtain this information from Yahoo Finance, and these are raw returns, okay? Essentially the percent change from the beginning of a month or from the end of the last month to the end of the current month, okay? And incorporating the effect of any dividends. You can either use adjusted prices for this or separately incorporate the effect of the dividend. I've also done that based on an equally weighted portfolio. So all the equally weighted portfolio is, as I've already mentioned, just add up all of the returns that you're calculating this over and divide by N. N in this case is these 10 firms, just the average of the individual returns. Market here. Now this would generally be a value weighted market return. So for your assignment, you would essentially go back to this thing here and you'd plug in return VW in for that market return. I encourage you to use that. Okay, if you want to use an index, that's fine. The problem with using indices is indices don't always, and in fact the main indices don't incorporate total returns. They're purely price indices. Okay, whereas if you want to get a feel for the overall return of the market, you've got to have a total return. Okay, and that by definition incorporates the effect of dividends, etc. I've done that in this calculation, right? So utilise this return underscore VW as the column for the market returns in your assignments.
But you wouldn't put that here, it's not the right
It's not, the months are different. The months are different, yes, correct. Okay. Now, depending on who's doing the calculating, they might be slightly off, okay, but they correlate very, very highly with different people's calculations of value-weighted returns. It depends on how many firms you include and so on, but the correlation is extremely, extremely high. So there's no need to worry about that. So the value-weighted return is accurate. All right, let's go and have a look at what's happening here. Risk-free rate, you basically incorporate your risk-free proxy. Make sure it's stated monthly. Very, very important. If you do not convert that rate from the RBA table into a monthly rate, you're going to end up with negative excess returns for all of your companies. Why? Because the risk-free rate is an annual rate, which you are subtracting from month. So it's going to be too high. It's going to be too high. All right. So this is what I'd recommend you do first, but only for your companies, of course, and of course for the 60 months that I've asked you to do this for. Now, down here, I calculated a separate sheet with risk premiums, and this particular sheet here should provide the basis for all of your regressions. Okay? So all I've done is I've simply reproduced the same information on the prior sheet, except each of these columns now contains risk premiums. In other words, the raw return minus the risk-free rate. Okay, so I've done that separately here to provide a clean representation of this data that you can simply use directly in your regressions. Equally weighted portfolio, same convention is applied here. It is simply the equally weighted return in this column minus the risk-free rate of return. Okay. Market risk premium, same thing. Okay, so your value weighted returns minus your risk-free rate is your market risk premium. All right. Now, here are the two columns of interest. Don't worry about the MOM. That's a four-factor model. I just included this here because I just wanted to show you that if you were to do, more extended kind of multi-factor analysis, you would simply include additional variables there. So what you would do is, here I have expressed these as decimals, so please again, make sure you either express all of this as percentages or decimals. Very important. Okay, it should go without saying, but a lot of people will get confused with these numbers. I just want to make it very clear, these are expressed as decimals, not percents. Okay? All right, so what these are, it shows that in this particular month, the return differential between the smallest firms and the largest firms is this figure here. Okay, that's essentially what I don't want to go into the mechanics of how I calculated this because it is quite involved. It involves partitioning and creating portfolios of the top 30 and bottom 30% of firms, etc. every single month. Okay, you don't have to worry about that. That was for me to worry about. Okay, you just need to worry about these numbers and how to use them. So essentially, here's how it goes. You have to run a regression. Let's make sure that, okay, so we don't have the add in there. Let's add the regression add in. It's in every install. It's already there, so I've already showed you this. Every time I log in, it's gone. Okay, I have to add it again. Okay, Excel options, add-ins, and you'll see a list of inactive add-ins. They're there, they're just not active. All right, so what do? We go down to Analysis Toolpack. Don't worry about the VBA one. Okay, you would also, for optimizing your portfolio, use the Solver add-in, but we don't need that now. Oops, I've done the wrong thing. Add-ins. Okay, you've got to click Go. All right, so don't click OK, click Go. There it is, and it's popped up over there, right? So how do we do this now? We're going to do this for each of the firms. Let's say that BHP is one of your companies. Not that it will be, but I'm just saying for whatever companies you've got. Okay, we click on Data Analysis. We go to Regression. Okay, your Y range is simply a single column, and it will be this column here. Okay, I might... There it is. Okay. And the X range, this will be multiple columns. This is a three-factor model, so we are selecting three columns. The first one will be your market risk premium. The second one will be the SMB values. And the third one will be HML. Do not, under any circumstances, subtract the risk-free rate of return from SMB and HML. You don't need to. Okay, this is a common mistake that people make. It's already done. Okay, it's already ready. Okay, all you have to do is under X range select those three columns in the way you set it up. Okay, but it's essentially like that. Indicate there's labels. We'll put it into a new worksheet. All right. There it is. All right. So what do we got here? Oops, I think I've jumped the gun. Okay. So let me get rid of this, because I have jumped the gun. The first thing I just want to point out, these things here, these are just the standard kind of CAPM implementation, the single factor. All right, so we've already seen these. So let me skip past those. That's the equally weighted one. Now here, this is what I just estimated. Okay, we'll do it again. I'll show you it again. Yep. All right, regression. Yep. Okay. There it is. All right, so this will be the output that you get. Now, unlike previously, so this is what the previous one looked like. You simply had intercept and RM. Here, we have four things. We have the intercept, which is our alpha, okay, which is our alpha. And then we have this one here, which is our RM, our market risk premium. That's our standard beta. When we're talking about a CAP-M sense, that's our kind of like our CAP-M beta, but controlled for these other two factors. And these are our SMB and HML betas. There's no need for you to do a test of significance. Just take them as given in your assignment and just report them. If you wish to discuss significance levels, that's fine, but don't waste away your words on that. Okay, I'm not requiring. I just want you to basically get in there, estimate these things, report what you find in terms of the coefficients themselves. So you could think of these three things here as factor coefficients, factor betas. Here's the beta on the market. Here's the beta on the SMB or the size factor. Here is the beta on HML, high minus low. That's the value factor. Okay, we call that the value factor. So it's like the CAP-M, but with the addition of a size and value factor as well. Okay, the betas should be somewhat similar, but not necessarily the same as if you estimated them purely using the CAP-M. Okay, so if we go over here, these are the same results which I've already presented. Now, if you go into the folder for this workshop, open up this is what you will see. Okay, you will see them like this. So it's the ones that are actually noted as 1. Okay, it's the first kind of subscript of this 1. All right, you don't need to provide plots, okay, because it's essentially a multi-dimensional security characteristic line. You don't need to worry about that, okay, but I'll just put that there anyway. What you're interested in here is really these things. Okay, intercept, that's your alpha, your market beta, your size beta, and your HML beta. Okay, and you do that for each of your firms. All right. Now, I've gone ahead and I've done something else just to show you that you can kind of expand upon this quite easily to an N factor. Okay, now, there's so many factors out there. There's literally hundreds of studies that have examined all sorts of possibilities of factors. The general consensus, though, out there in industry, the CAP-M is widely used, the 3-factor model is used, but especially in academia, something called the 4-factor model is used. And what the 4-factor model is it's exactly the same as the Farmer-French 3 with the addition of what we call a momentum factor. I'll talk a little bit more about momentum tomorrow in tomorrow's lecture. Okay, momentum is a market anomaly. Okay, so I'll talk about that tomorrow. But I'll just leave it at that. But it's another factor that basically controls for high momentum versus high positive momentum, negative momentum stocks. Okay? And that is, momentum basically is, if we look historically at the past 12 months of all firms, what's the top 10% of firms in terms of their return? Okay, that's high momentum, negative momentum. So we look at the difference between those two types of stocks as a portfolio. Let me just move over a little bit here. Okay, so these ones here, these TLS1, etc., these are your Farmer-French 3, and then I've gone on and I've done this one with the number 2 with the inclusion of the momentum factor. These figures here should be they won't be the same. They will never be the same, but they'll be similar, the magnitude. We're controlling for an additional factor. Okay, and I've done that for each of these stocks here. But then what I've done, and I think you should do something similar, okay, but purely for the index model and the Farmer-French 3 is to present something like this. I've put together a summary. Now, you may wish to just do it for betas. If you want to do alphas, that's fine. But what I've done here is I've just provided a presentation of all of those results in a single sort of set of tables, okay? So I have 10 firms, and I also have an equally weighted index, okay, and I've estimated the regressions for each of these stocks and also for an equally weighted index of those stocks. And these are the results basically put together for each of those regressions, okay, for the intercept only. These are the alphas basically, all right? And I've also included standard error and test, things that enable you to test the significance of this relationship. All right. Something that's quite important, once you add more and more and more stocks, generally what will happen is your alpha will tend towards zero. Okay, that's usually what will happen, because the positive alphas of some stocks will be offset by the negative alphas of others. Okay, we've only got a small sample here, and your sample is even smaller, so don't worry about there being a particular relationship there. Now, the Farmer French 3-factor model, I've done the same thing. The argument goes that with models such as the Farmer French 3 and also the 4-factor model, the argument is that you may get a better representation of what the alpha is. Okay, so that's the argument behind using that. But you'll note that these particular intercepts are quite similar, although if you get into the 4-factor model, you can see it's actually far more conservative in what you've found, okay, because we've got that control of that additional 4th factor. This would be of more interest to you. That's just a summary of the betas. And I do encourage you to make use of tables, okay, as much as possible, but don't tabulate unnecessary information. Get straight to the point. If you've been asked to present betas, for example, present the betas. Okay, don't present a whole bunch of other things. Get straight to it. That way the reader and, yep. Sorry? Okay, so these particular betas, yeah, these are just the market betas according to each of, so I haven't reported the additional betas. I've just, yep. Now you might want to, I do encourage you to report the SMB and HUL betas as well, but I've just done this to provide you with a bit of a contrast between what the market betas look like according to each of those methods. Okay, but certainly do include the additional betas that you've done for the Farmer French 3. Yeah, so that's, if we go back to the results and we pull up the market risk beta, okay, the market beta, that's what it was under the Farmer French 3. So it's higher. So note that they're different, but they're not markedly different. Okay, which one is more accurate? It's really an empirical question as to which one is probably more valid. Okay, you don't need to worry about it. Okay, but some argue that the inclusion of especially Farmer and French and all of those people that have used their model, I use their model in research that I do. It's really pretty much the gold standard. Okay, in academic research, especially the Farmer French with the momentum factor, okay? But they have a series of papers that kind of examine betas under these circumstances. But please note, they're not identical, okay? They are different, but only slightly so, okay? But do make use of tables. Don't just sort of put down raw results. It'll make it really, presentation is really important. Okay, so the person marking your assignment looks at it, oh, yeah, here's where the betas are, this is what you got, great, we can get a really clear picture of what's going on. Okay, but do have a really good look at this spreadsheet, okay, and how I've done this. Have a look at the data that I've shown you, okay, I've put it on Wattle in terms of, again, I'll just point out where they are, that way there's no confusion. So this particular file, AU returns and factors, won't save that, don't need to, that's the thing there. So if I go back to the main page for the course, the home page, if I scroll down to course announcements, risk-free rate proxy data, that's where you get your risk-free rates from. Make sure you convert them to monthly rates. They are stated as annual rates, okay? Make sure you do that. And also here's our Australian market return data and Farmer French factors. Okay, so click on that, you'll have both of those pieces of information ready for you to plug into your assignment to undertake your regressions. Okay, are there any questions? All right, I only wanted to present this purely to kind of give you a little bit of help along the way. Okay, I do realise, given the nature of today, there's fewer people in this exams, which is fine. Okay, but do have a look at this stuff. All right, and if you have any questions, do contact us. We're happy to help you to a point. We can't do the assignment for you. We can't give you the answers. But we can sort of speak to you. If you have a question, how do you generally do this? We can provide you with guidance on that. Okay, so don't be shy. Come and have a chat to us. Okay, any final questions?
Are you going to mark questions from today's exam?
Absolutely. Look, it's amazing. one number can makes difference, right? The question was water, it was completely tight. It was a nice question. But one number can make, but that, yeah, so the way I'm gonna mark that is by basically your workings, all right? So don't worry, it's got to do, did you show the formulas necessary in which you do this? So I'll be super lenient, don't worry. Okay, my job is not to make things particularly stressful. That was unfortunate, okay, but yeah, I don't want anyone to worry about that. Everyone will be happy with the outcome. Okay, yep. All right, any other questions? All right, thanks folks. Is there anyone here still in need of a group? If there is, just send me an email, okay? Because I've had a few people that are still groupless in spite of all of the happenings on the discussion forum. Thanks.
Just some minor questions, like on the risk-free proxy, because I've basically done
good, excellent.
Everything.
Yep.
Yeah, a lot of stuff. But basically it's just the risk-free proxy.
Yep.
Because for a risk-free rate, it's annualized. So the way that I actually calculate it is like 1 plus the annualized rate.
Yep. That's fine.
Yeah. To the power of
whether you can either do that or I don't, because we don't know the basis in which they've converted that monthly, because there'd be a monthly rate behind that. There's no explanation as to how they've annualized it. So that's fine as well.
Yeah, but like, wouldn't it be super strange that in a sense you get a figure that you de-annualize it, but it's so insignificant? Like,
it's very tiny. Yeah,
Very tiny.
and that's true, because remember it's monthly. And if you think about the annual, what is the cash rate? If the cash rate for a given year is 2%, divide that by 12 or convert that, it's really tiny.
So it should be really tiny.
Oh yeah.
Okay, so like, yeah.
Yeah, that's absolutely true. Okay, it will be tiny, so don't worry. And yeah, that's a normal question. If that number is big, that's the problem.
Oh.
Okay, it's got to be tiny. It could be 0.000 something, right?
Yeah, like 2 or 3 digits.
Absolutely.
Behind.
Yeah.
Okay.
Okay, you're on track.
Okay.
Yeah.
Thank you.
Yes. Hello.
I have some questions about
Yep.
this part in the CAPM.
CAPM?
Yes, like the testing of CAPM.
Yep.
Like, I just can't seem to understand the approach to it.
Okay.
Especially like the average part in the assumptions.
Did I give an example in the lecture on that? Maybe I did, maybe I didn't. So what you do is there's basically two things you've got to do, okay? What I might do, if I log into Waddle, I'll just show you quickly. I might not have released it.
Or is it in our tutorial?
You will have done something in the tutorial on that.
We did it
you
for
will,
this
there is a tute question on it, but there's also a... Oops. There it is. It's HTTP. There is... Okay, I think it's still hidden because I didn't go into much detail on it. What I'll do is I'll reveal it because I wanted to wait until after the tute is held. There it is. So if we scroll down to week 6, see that?
Oh.
I'm going to reveal that, okay?
All right.
I just wanted to wait until after the tube, but I may as well just reveal it. That's fine. So this here is just what I showed you, okay? So don't worry about that. That's available in... Okay, so if I open this, I basically explain, and I believe I did explain it in class briefly, but what this is, these are the average returns over the 60 months for each of those companies.
Okay.
What we do is the first stage is estimate the betas for all the companies. Okay, the second stage is regress the average returns for each of those companies over the 60 months onto the betas. Okay?
Okay.
Okay, so that's the average
Oh, yeah.
market return. Okay, so that's essentially what you've got to do there. Okay, this is the output, and there's certain implications of this. You're essentially testing that the beta equals this, and that the alpha equals 0.
So why are we testing the beta to equals that and alpha equals to 0? Like,
Yep,
why?
because according to the CAPM, the alpha should be 0. That's one of the theoretical bases of it.
Oh, like there's no errors.
Correct.
No firm
There's
specific
no
errors.
correct. Well, yes, and also there is the intercept is 0.
Oh,
Okay, so that's
okay.
okay. Then in fact, because the CAPM, so there's two things. There's no errors, so all firms will lie on the line, and the intercept will be 0.
Why not RF? Isn't it RF for intercept?
No, not in this particular instance. So so you're thinking about the security market line. So different representation.
Oh, so it's a
Okay.
different graph, is it?
Yes.
Oh,
Yes.
wait, because this one, it makes me think of the, the excess return one. I think it's... I forgot.
SCL. So this will be the SCL, right?
Oh, so this is the SCL.
It'll produce an SCL. Yeah.
So alpha equals to 0. Alpha is the... it's
0,
not- alpha
and the
is
beta from the beta from the second stage should be equal statistically to the average market excess return. All right, and it's actually not. Okay, so that's minus 0.015, etc. Here it's So that's how the early tests kind of tested it. I think we need to exit the room. Oh, we've still got a few minutes. Yeah. All right, but I've just revealed that. Do go and have a look
Okay.
at this, and try and actually replicate this using the data that I gave you in workshop, because it's basically taken straight from that raw data. So we go to workshops. Still going?
So the alpha, we said alpha should be equals to
0,
0
yep.
because you are saying that it should be on the line of the SM.
Well, it should be through the origin. It shouldn't be above or below. Like it should be 0.
Okay.
Okay, so that's not opening. Oh, here we go. It's probably an issue there. Okay. But do have a look. I mean, what I just showed you, the data I just showed you with BHP and those 10 firms, that's what it was calculated using. Okay, so use that data and try and replicate that, and that'll provide you with some practice on testing the CAPM.
All right.
Okay, you should get the same answers that I showed you. Yeah.
This is I'm wondering like why the hypothesis is such and such.
Yeah.
Because it doesn't make
It's just
sense.
one of the implications of the CAPM is that the alpha is 0.
Oh,
Yeah.
all right. Is there any intuitive behind it?
Is there any intuition behind
Yeah.
it? Because it's got to do with the fact that every investor will hold the market and the risk-free asset in some proportion.
The
And if-
assumptions.
Yeah, it's got to do with the assumptions. Yes. So the idea is individual companies, they may be out of whack and they may present some positive or negative alpha, but in equilibrium, the alpha will always be 0 because of the assumption about what investors hold. They hold the market
Okay.
and the risk-free asset in some proportion, and if that's out of whack, they'll rebalance their portfolio to eliminate that.
All right.
Yeah,
Okay.
yeah.
Got it.
All right.
Okay, I just got two questions.
Yeah, you're right. Yeah.
MOM.
Momentum. Yeah.
Momentum. Was that on the spreadsheet that you
Yeah,
provided?
it's on the spreadsheet. I'll explain what momentum is in the lecture tomorrow.
Yeah.
It's momentum. You don't need to worry about how that was specifically
Is that
calculated.
is that something to do with the bull market and the...
Kind of, yeah. So some companies will perform very well over, say, the prior 12 months.
Yeah.
Some will perform very poorly. It's looking at the difference in returns between those two groups of companies. But we'll talk about the momentum anomaly a little bit tomorrow.
Yep.
because there's actually evidence that one can actually create a long-short strategy to
Yeah.
profit off of that.
Right.
Yeah. All right.
Also, I heard that, so there were 2 exam venues, right?
Yeah.
Apparently one exam venue, the one that I wasn't in,
Yeah.
got an extra 15 minutes.
Oh, really? Yeah. So
Do you
I
plan
can,
to do-
yeah, I'll fix that up. Okay, I'll sort that because that, yeah. So
Because I was really rushed on time because of that question
because that.
too. And then
Did
I,
you?